Excellent.
This is kind of a continuation from Monday, but if you weren't there, that's okay.
Yeah. Monday we were talking about, so you've got this code, nobody understands it, you're not totally sure it works, there's things about it you're pretty sure are bad, and we were focused on how the code functioned. And this time around, we're unabashedly about how it actually is to look at, to read, to try to change, to understand, and to possess as a sort of asset. And so we think C++ code does not have to be ugly, and we think beautiful code is better code. I'm guessing pretty much everyone here works in multiple languages, and more importantly, that you have friends who work in languages other than C++, or even friends who aren't programmers at all. And when I tell people I'm a C++ developer, they say some intriguing things. So partly they say like, oh, you can do some really cool stuff, right? Because it's such a fast language, and it's really powerful, and you must be smart because that's a language for people who are super smart. But they also say, but it's so gross. Like, it's hard to read, and one of my friends tells me it's just a bunch of comic book characters swearing at each other. And so I made that out of legitimate C++ operators. And they also say, like, oh, I can't use C++, I'm not smart enough. And I don't like that. Like, why should it actually have to be smart people's language, right? You can do incredible things with it if you're smart. But why should it be a language that ordinary people can't understand, or you have to be a rocket scientist putting things on Mars in order to be able to read C++ code? So there's actually no requirement. Probably several people here have got the standard memorized. There's nothing about how smart you should have to be, right? Or how ugly your resulting code should have to be. So that's what we're here for. Anybody like this? Hands up. Gee, James, nobody likes this code.
We don't like it either.
But there's that whole like, well, it was hard to write, it should be hard to read, right? I'm a big, tough, clever programmer, look what I did. And we want to be like the opposite of that. If you weren't in the Monday talk, or if you've been to 6 other talks since then and that part of your brain has been overwritten, you've had some sort of cache invalidation problem, we'll just recap what we did then that we will not really particularly be repeating here. Turn your compiler warning level up. Stop writing C. Do not use if-defs unless you have to, and be pretty strict on your definition of have to. When you have to, keep them simple. Embrace RAII, exceptions or no. It's not just like, oh, you need this if you have exceptions. You need this, and we'll be talking about that a little bit more this time around. Try to keep things linear and readable. Const is your friend. Lots and lots of const. Not just if you need to, but unless you must not. And stop using round bracket C-style casts. Either don't cast at all or use a proper C++ cast, which will express your intent and add to your readability as well. It's just a petty little consideration, but it also might be relevant for correctness, if you care about correctness. So that was Monday. What we're going to talk about today is things we think are ugly and things we think are beautiful. And I guess it's sort of an implied action. If we think something's ugly, that means don't do it. If we think something's beautiful, that means do it. So macros are ugly. Walls of code are ugly. Lambdas are beautiful, sort of. Invisible code is beautiful in a way you really cannot appreciate until you've ripped out several hundred lines of code. Removing effort is beautiful, and this one I think probably the hardest for people to accept. Other people's code is beautiful. I know, like other people's babies, right? Like you say, oh, what a beautiful baby. Wow, he totally doesn't look like a frog at all. But other people's code is beautiful. And finally, we're going to wrap up with comments are ugly. Have a rant.
All right, so does anybody here love macros and you love using them all over the place and, love how well they work? What? Oh, we actually have somebody raising their hand. This is amazing. So there's two kinds of macros, and one of them are object-like macros, so they're the normal kind where, you like pound define blue to be 3. There's no encapsulation for macros, obviously. They have no type. It's purely literal text replacement or token replacement. So in most cases, you can use enumerators or static const variables for constants, except the one time you might not want to do that is in headers that are shared with C code. But certainly in pure C++ code, there's very few good reasons to use macros for this. There's also function-like macros, which are the kind that take arguments, and they have horrible expansion issues, and with expressions that have side effects, especially. There are certain places where it's certainly helpful to use these, especially one example Kate and I were talking about is if you have debug code like an assertion that you want to use the __ line predefined macro. But generally, we want to avoid using macros for that purpose. So macros obviously pose numerous problems for maintainability. They don't obey the normal name lookup rules. They're evaluated before the compiler has any type information, before it even parses the code. And they're used far more frequently than necessary. So, here is something we might have done in C. We're like, oh, we've got a whole bunch of colors, and we'll define macro constants for these. And then, of course, sometime we've got some other code and we try and, oh, now I want a variable named orange. And, well, that's not going to work because, you try and compile it and the compiler is going to become very irritated because, of course, all the compiler is going to see when it parses the code is unsigned 2 equals this hexadecimal constant, which is not even correct. So another problem is that, especially in C, this comes up, that oftentimes people will do this and then they'll have a function that takes an int and they'll just say, oh, just make sure you only pass colors in. And okay, well, so that works, but then you can go and pass any other int and there's absolutely no checking. So the quick and easy solution here is to use an enumeration. And with enumerations, you get the added benefit that if you're starting from 0, you don't need to go and specify all the values so you don't accidentally mess up and have 2 with the same value or skip 1. And so, for example, this one, we could even condense it all down to 1 line if we wanted. And this solves our problem of, oh, well, now you can't just pass any arbitrary value. You could with a cast, but again, if you're using a cast, then, that's a sentinel that, oh, there's something, fishy about this code. There's something I know that that's kind of not the right thing, perhaps not the right thing to do. But normal enumerators have, this problem that they're implicitly convertible to their underlying type. So for example, here, if we have an integer x, we can assign red to it, or we can even add red and orange, and we get, some behavior that is probably not what we're looking for. Sometimes this can be useful, especially for bit fields, if you want to, have a whole bunch of flags and you want to be able to compose them using the bitwise operators. But generally for normal enumerators, that's not what we want to do. We also have the problem that the enumerators themselves are actually declared in the enclosing namespace, not as part of the enumeration. So if we had like a color type and a traffic light state, well, the compiler wouldn't like that very much because now we've got multiple definitions of some of these. So enum classes solve that. The one disadvantage of enum classes is that you can't they aren't implicitly convertible to their underlying types. You can't use them for flag types, or you can't use them easily for flag types without overloading a bunch of operators. But you can static cast if you need to convert them to their underlying type. You can also use these for just ordinary constants. So for example, or you can just use enumerators for ordinary constants. In C++11, you can declare, hey, I want explicitly this underlying type. So for example, whereas we might have had, max _ uint32 in a C header, you can actually use an enumerator for that and say, hey, I want this to have this type and this value. So for name constants, like almost anywhere we can use enumerators. It's also common to see static const variables used. So the second category are macros, that should be functions. And the This is actually an example from one of our code bases that takes a character and it makes it lowercase if it's an uppercase letter. And it mutates the variable in place. And of course, this has a problem if, say, we want to write a function that takes a whole string and makes the entire string lowercase, and maybe we think, I'll be clever and we'll just call it in a loop until we reach the null terminator. And this has the problem that, of course, the compiler isn't going to see this. It's going to go and replace the macro in place, and now we're actually incrementing that pointer many times, and this is not at all the effect we wanted. So we can always transform, or generally we can transform these function-like macros into actual functions. We can make the code an awful lot cleaner. And further, if the compiler thinks it's valuable to inline this, it's going to go and expand it inline anyway. And something like this, I would absolutely expect to be expanded inline into performance-critical code. So, to recap that. I think since only one person in here said that they actually liked macros, I expect most of this is familiar to people. But avoiding them, is absolutely best practice.
The good news is that if you were putting up with them because you thought you didn't have alternatives, you have alternatives, especially, and now that we have a new classes. Now, I'm not going to show you examples of wall of code. I think we can all agree that when you walk onto a new project and someone's like, oh, it's really simple. We have this 5,000-line function that does the important stuff. And then there's some little bits of cleanup elsewhere. It's really hard to read, to understand, and to figure out what's going on with that. And that ugliness, it's not just an aesthetic objection. The older your code gets, the more people have to read it over its lifetime. And the time that's being wasted because people don't know what the heck it does is time that could be spent doing more important things. So much of what we're going to talk about throughout the whole course, throughout the whole hour, is about connecting back to that wall of code and fixing it up. But sort of in general, what we're thinking you should do is split it up. When you split it up into a function, the function gets a name. That's super cool. And all the arguments get names. And those two things on their own are often enough documentation for what's going on. So if you need to sort something and then, split it into two pieces and then calculate the total price, when you had, 300 lines and then 300 lines and then 300 lines, maybe nobody indicated those breakages in any way except for maybe one line of white space or something. But now if you write it out into functions and they're called sort and find biggest and calculate price, then, gee, I wonder what this function called calculate price does. It's possible it calculates the price. Now, some people, when they start writing functions, they start getting all wrapped around the handle about how they should pass their arguments. And I've spent the last month or so watching people arguing about arguments and, should we pass it by value? Should we pass it by reference? What if I'm going to move from it? What if it's expensive to move, cheap to copy, blah, blah, blah. Premature optimization is the root of all evil. So you have tests, right? So just start out passing things whatever way is obvious and intuitive. And if you later believe you're causing a perf problem, you know what to do. You measure, you prove it, and then you fix your perf problem, and not in advance. And especially not with just memorized rules, because most of your memorized rules about how to pass and return things, you can find someone smart who will tell you that rule is no good anymore. They might even be right. The other reason that people write walls of code is that they have types in their head that are not in their code. Right? So they have 4, 5, 6 variables that kind of belong together, and maybe their names all start with the same first 4 letters or something. And they're working on them in these clumps. Let's do something to employee's name, and then we'll do something to employee address, and then we'll do something to employee phone number. And when you find this kind of code, it's showing you that there's types in here. You can make an employee type, and then guess what you can pass off to the function that you just refactored out. And when you finish doing this, you actually end up with something that's readable and that tells its own story. The other place, speaking of things whose functions in this case all start with the same 3 letters, is all those functions that start str. The worst wall of code stuff you can find is characters being manipulated, people going, whether it's uppercase, lowercasing, finding things, stir talking, whatever. Man, I just love to get rid of car stars and make strings instead. And that just makes code shorter. Much, much shorter every time.
So this seems to be a very popular topic at this conference, not only Lambdas, but just in general making code better. Kate and I were sitting in the keynote yesterday, and we're like, I see Dr. Stroustrup is covering much of what we had had planned to cover. But Lambdas can make code, very beautiful. Maybe not so beautiful to look at unless you really like braces, but they're so useful. This is a Lambda example from the C++ standard. I don't know what it does. Jonathan showed me this some time ago, but we should
clearly rotate.
This is clearly beautiful. But there are many cases where Lambdas really are useful, and the obvious example that everyone brings up are, hey, now all of the standard library algorithms are actually usable in real code. We don't have to go and write separate functors or do weird things with function pointers, or like the Boost Lambda library. And this can make code much cleaner. We can go and create threads. Since they're implicitly convertible, if you have a captureless Lambda function, it's implicitly convertible to a function pointer, and you can go and use it even with legacy C APIs that just take a function pointer. As we showed in our talk on Monday, we can use it for implementing exception boundaries, so you can use it as a technique to basically encapsulate code that uses exceptions and throws, so that you can start introducing modern libraries that use exceptions into code bases that are not exception safe in general. Another place that, or another technique that I've started using with Lambdas is if I have some complex variable initialization. So this is some code from an open source library that I was working on for basically creating a type universe for reflection. So it would load up a whole bunch of metadata files, and so as part of that, it has to resolve types across different metadata files. So you might have one type food defined in one file, and it has a member of type bar from another metadata file. And so, one of the things we have to do is go and parse and figure out, okay, where are we going to search for that? And so in this particular piece of code, we were like, okay, let's go find the target scope, which is of type, it's a database. And here we've had to make it a pointer. We'd really love for it to be a reference, but you have to initialize a reference when it's declared, and you can't change what it refers to. And here we've actually got this rather complex switch statement that goes to figure out, where am I actually going to look up this type? And so because of this, basically we've got we've made this a pointer, and we've had to go and take the address of all these functions that already return a reference, and so everything's very modern. But we can't, there's no way to resolve this directly. One thing would be certainly to split this switch statement out into another function. But we have the problem that we use five local variables here, and this is the only place that we actually do this code. So we would have to create a whole separate function that takes 5 arguments, and we have to pass 5 arguments from this function. There's really nothing about those variables that relates them together, except that they happen to be used from this place. And so one technique that you can do is you can actually use a Lambda for complex initialization. And so here what we do is we've turned the variable into a reference, and then we've initialized it by declaring a Lambda and immediately calling it. So you can see at the very bottom there's an open and closed parentheses. And so basically within the Lambda we can do all the complex stuff that we need, and then we can just return whatever it is that we want to initialize that target scope variable with. Now, this isn't necessarily the best idea for all possible complex pieces of code you might want to refactor out. Certainly, refactoring into a named function can make more sense in many cases. But there's times when that doesn't make sense, or where it makes it more difficult, or where moving the code to be somewhere not local just adds complexity that you don't want to have to deal with.
Yeah, that's huge to me, the non-locality.
Yes.
When you're calling some algorithm and you're passing in some function pointer that is like in a whole other file. And then I know the IDEs help you, but it's nice to just see what's happening right where it's happening. Or alternatively, to not have to see what's happening because you trust what's happening and you don't have to go look at it, which is kind of what we're talking about when we say that invisible code is beautiful. Somebody asked Herb for his favorite C++ snippet or idiom or something, and that was his answer, close brace. And I support that. A lot of amazing stuff can happen on a close brace. Things are going out of scope. Destructors are happening. Cleanup is happening. You don't see those things being called. You know they're happening. And that invisible cleanup code is if it's not invisible, absolutely awful and ugly. And making it disappear so that you don't see it being called, to me, is a big part of letting what your program really does for a living show through. So if you think about your cleanup code, if you have catch blocks, I mean, I come in and help people when they're stuck on some of their projects. And when I see a 10-line try followed by a 200-line catch, it's like, what? But I see that. And my record for go-tos in a catch block is 3 in the wild. You may have found more, but it's pretty, what are they doing, right? What they're doing is they're completely obscuring what their code is supposed to do with the chrome of getting things set up and, more importantly, of getting things cleaned up. And so taking all that cleanup code away so that you don't have to see it unless you want to go read a destructor, to me that's absolutely critical to being able to have your code express your intent. That's something that's become really important to me.
So really when we say look at your cleanup code, don't look at your cleanup code
Well,
because there's nothing to look at.
Yeah, look at it once and then stop looking at it. So I took a several hundred line function that was in real working code that was first written in 1997. And I went through and I stripped out a lot of the logging code and hey, we got to line 402 and all that kind of stuff. And this is the sort of bones of it that was left behind. For the function starts with a label, so you know somebody's going to be going to it. And it's full of wild truths. Like I can't tell you how many wild truths it's full of, but you can see what it's trying to do. It wants to make a connection. And if that fails, it wants to try a couple times to reconnect. And if that really fails, then it's going to go to exit thread loop. The one interesting line on this whole slide is down there at the bottom, open connection, and it's hidden, right, in housekeeping. When you get to the catch that goes with that try, we got more housekeeping. Like, well, depending on what I just caught, maybe I'll do the go to reconnect, which is going to count whether we tried 3 times or not, and then give up and go to exit thread loop. If we're catching anything that's not these special cases, we're going to go to exit thread loop, and then we're going to catch ... and go to exit thread loop. So you're like, oh my gosh, what's waiting for me at exit thread loop, right? Well, a very large amount of code, and I won't show you all of it because it sort of looked like this. If something that I've been turning on and off true and false throughout the previous 400 lines, then I'm going to call, in this case, release semaphore. But there were any number to clean up this, close that, delete that, whatnot. This is telling you RAII, right? Because, I mean, I know it's a horrible name. I know we're really, really bad at names, but resource acquisition is initialization, in my opinion, should be just given the opposite name. Initialization is resource acquisition. So the resource that you're acquiring is the semaphore, right? So if I need to release a semaphore is like if this object is in scope, right? So we already have that mechanism for, hey, if something is going out of scope that successfully came into scope, run this code. And so you might be like, oh, I know, I just need to write a class that wraps the semaphore whose destructor releases it. No, you need to find a class that wraps this. Come on, this has been done, right? So don't write this or really many of your resource managing classes yourself, but do start using them. So whatever the things are, your connection, your file, your locks, your mutexes, your whatevers, it's been done to wrap those up and to be able to release them on the destructor. When you do this, and I've done this in live code bases, and obvious things that happen like, the code gets shorter. In some cases, the catch blocks can go away completely because, when we throw, things go out of scope, destructors go off. We don't need to stop and catch and deal with things. But some surprises happen. Every single time I've done this on a project of any decent size, it turns out there used to be bugs. It turns out that when people are going through, they'll be like, oh, and there should also be over here in the else of this, we should be, so I can delete the call to release in there. Oh, we never had a call to release in there. Oops. So when we finish doing this, there is actually now a proper consistency in cleanup. And some mysterious long-running memory leaks or other intermittent bugs will often magically disappear when you actually get right and consistent with your cleanup. And that was not a benefit that I expected when I first started doing this to people's code. If you've made nice classes, then typically people will be like, oh, I made the constructor, I made the destructor. But when we're talking about that wall of code effect, it may very well be that also some of your wall of code is member functions of this new class that you just invented. Now, when you were doing that Lambda example for the complex initialization, it didn't deserve to be in a class or a function, but very often these things do. And then when you go to the trouble of coming up with a name with it, that's when you suddenly realize, oh, you know, that's what this big hunk of code in the middle here is actually should be a member function of this class I just invented. So rather than sitting at the beginning and trying to think about encapsulation first, if you dive in to make cleanup right, you may find that you lead yourself magically into some of the other refactorings that you need to do. And most important to me, I got 5,000 lines of code, 13 of them matter. They do whatever it is that this code does, like it makes the rover go around the corner, or it adjusts the temperature of the nuclear reactor, or whatever it is we're supposed to do. And the other like 4,977 lines are all like open this, release that, if this, check to see if I acquired da-da-da-da. And so when you come and you try to read this code, you have no idea what it does. When we take all the cruft away, you end up with something that you know what it does, and that's immensely valuable.
So anything that we can do to make our code basically easier to understand so that when we first look at it, when we first look at a new function that we're not familiar with, anything that we can do to make it so that you look at it and you know immediately, okay, this is what it's doing, is beneficial. Certainly it makes it easier to maintain. It makes it easier for new people to join up on a project because they can, the code is not unapproachable. It also makes it easier to test because when you can look at a function and know, okay, here's the important pieces of it. I can write tests for those important pieces. And it's also good because code that states your intent clearly, is easier for everyone. Code that cannot have certain mistakes, is easier for everyone. Any kind of code that you've eliminated possibility for off by one errors in loops, for example. So there's a couple of techniques that make this very convenient, including in C++11, the range-based for loop, the algorithms that we've had for a long time but have finally become usable, and auto for type inference, though only perhaps in moderation. And so, for example, I think people have probably seen this 4 times now at the conference.
This should be the T-shirt, actually.
It probably should be the T-shirt, yeah, or not this one, but the improved one. But we might have started with a loop that yes, it's great. We're using iterators, which is better than using indices at least. But we've got to name that unwieldy type, and we can certainly fix that by using auto. And this is an excellent usage of auto. This was always the T-shirt version of yes, this is why we want auto, is we don't want to have to name that silly iterator type. The range-based for loops make this better because now we don't even have the iterator. We could even use auto with that if we wanted. That's more characters in this case, but that's probably okay. And thanks to Stefan, who I think is sitting in here somewhere. Yeah, we in C++14 now you don't even have to say auto or anything, and it'll just automatically be auto ref, and which is the right thing to do.
17.
See, I'm sorry, it's C++17. That's the second time I think I've been corrected on that. Of course, if we wanted to, we could do this with std copy and an ostream iterator, which I don't know. There's someone on Stack Overflow who is always recommending this pattern, and it's always entertained me because I don't know that I've ever seen this done in real code. So, for each with a lambda makes this much cleaner and much easier to read. You don't have to deal with all the restrictions that you have with the ostream iterator, and certainly the ostream iterator is mostly just a hack to try and enable use of the algorithms with that. And the best part is that yes, there are so many useful algorithms in the standard library, but in addition, it's generally easy to write your own when you need to, and oftentimes you can write them in terms of other algorithms that already exist.
How many of you really want to use someone else's code in your project? So that's like a quarter, yeah. And I really need everybody to embrace the idea that you do not need to write all of the code in your project. You should write all of the code that's about telling the rover to turn left or checking the temperature of the nuclear reactor or whatever, because that's the stuff that you do for a living. But, the linked list, right? We don't need to write the linked list. And I think most of us, we draw the bar in the wrong place. So we're prepared to embrace that we should not write linked list, but then we're all like, I need to parse some JSON. So be right back, writing a JSON parser, because, it was only invented this morning, and therefore no one has possibly written any JSON parsers yet. So you should totally spend the next, and what is it going to take, an hour, hour and a half? I mean, JSON's pretty simple, yeah. And then I see you in 3 weeks, and you've missed all the edge cases, and it's all awful. So we really want you to move your line for the stuff you're prepared to trust a little away from, well, if it's in the standard library, I'll use it, otherwise I won't use it. That's all. So why? These things have names. And as we said before when we were talking about refactoring, even if it would only be 10 lines or 100 lines or 1,000 lines for you to do it yourself, calling something with a name carries information. Calling something with a name that's been documented by someone who isn't you means there's a good chance that anyone who cares can go look up its complexity or whatever other information they need about it without you having to do that part, because it's not enough just to write the code, but maybe you might also want to be able to document or explain the code to people who are going to come and ask you questions about it. And if it's someone else's code, you don't have to answer those questions. That's an indirection that I'm happy to undertake. And of course, hopefully that person tested it. Hopefully that person changes it as the world changes around it and so on. Obviously, the whole standard library is there, but there's a lot more. And I thought I'd give you this little digression, because we have no animal pictures in our talk at all. And we want to be well evaluated, so we put this picture, and I took this picture. But I didn't show you the picture to show you the picture. I showed you the picture to show you the canoe. Because I built this canoe in 1985.
Before I was born.
Yeah. The canoe is older than James. And I took this picture last year. So the canoe is still beautiful. And it's made of thin strips of cedar, and then it has fiberglass on both sides of it. And most people, when they meet the canoe, they tell me how beautiful it is. They give me all kinds of praise. And recently, a C++ programmer got a chance to look at the canoe, and he said, I'm not making this up, did you cut the wood into the little strips? And I felt like inadequate for a moment, Like, I love this canoe, and it's taken me on a lot of great vacations. It's absolutely gorgeous in every way, but I bought the strips of wood like some common peasant, And then I put them together over a mold, and I nailed them together, and I put fiberglass, and there was a lot of sanding and everything. But geez, I didn't cut the wood up myself. And you know what else? I didn't even grow the tree. Like, just use some store-bought tree, I would like it if we didn't grow the tree and we didn't cut the wood into strips, but you can still build the canoe, okay? And that's really what we're talking about when we're talking about going out there and using libraries, that you don't have to do absolutely everything yourself from scratch. So where would you find a library? I mean, there might be a few, just a handful. Well, all the world's knowledge is, of course, in Wikipedia. So they have a category called C%B% libraries, because we're all proud C%B% programmers, which is, among other things, a great example of how we suck at naming things as an industry. Here's a random selected screenshot. It goes on. There's a lot there, and there's probably thousands more that aren't there. But if you're not looped in, I don't know how you decide whether or not you need to use Ogre, because I don't think it smashes things with its big hands. I don't know what Ogre does. If you do, yay. But you could certainly poke around in this giant alphabetical list of C++ libraries. They got MFC in there, among other things, if you scroll down to the M's. But more realistically, all you really need to do is just kind of flip that bit in your head so that the next time you need like a JSON parser or something to extract zip files or some kind of image manipulation, face recognition, whatever, instead of going out to search for how do you do that so that you can spend the weekend writing that, because it's only going to take the weekend, search for the library, because there's probably one there. There are some great libraries that are super accessible and completely free that will solve all kinds of complicated problems. The first time someone showed me how to do face recognition, and I'm like, wait, what? Because the only hard part was wiring the library, and that part was all done. Even if they're not free, though, when you do the math about how many hours they represent, and you're like, 4 hours of my time. It's more than a weekend, so yeah, I guess I should buy the library, right? So going out and looking for things, if you were at the lightning talks last night, who was at lightning talks last night? Right? Ordinary differential equations, matrix manipulation, eigenvalues. I mean, you could have gotten your college textbooks out and done all that, or you could use libraries like Eigen that do that, right? So looking for libraries and having a different default position that says, I will, for the non-mission critical parts of my code, use other people's libraries, and becoming aware that they're there, that's actually going to give you a ton more time in your life to do the things that you care about. And as a side effect, there's a really good chance that the library is somewhat better on things like edge cases or documentation or maintenance as the world changes than what you would have rolled your own. And then we talked about good stuff for too long, so we got to rant some more.
Okay. I think I can rant a little bit about comments. So first, not all comments are bad. There are some good comments. But how many people in here, for example, think that, maybe every function we declare should have a little comment saying what it does? Do we think that's a good idea? Okay, a few people. So here's some actual code from one of the projects for which my team is responsible, and each of these functions does have a nice little comment telling you
Do you feel
what they
enlightened
do.
now?
Is this helpful? So, I mean, there's literally no useful information in any of those comments. Like, clearly that is a default constructor, and clearly that is a copy constructor, and it takes a source object from which it is hopefully going to copy. And, literally, like, you could get rid of all those comments, and you have exactly the same amount of information. Similarly, oftentimes I've seen code like this, and it's like, this is not useful. And maybe you could even go with longer comments. And I have seen code that has in a comment next to an enumerator, and its value is this. And like in this case, it's wrong. And I've seen it wrong. And like, you may as well just not add comments for those sorts of cases. Here's another example from our C library implementation. And actually, these comments are kind of beautiful. Like, somebody actually took the time to go line up the beginnings of the comments. They're all there together. So now you know what all the local variables of this giant 500-line function are. But are these comments really useful? I mean, that variable is named bytes read, and the comment says number of bytes read. I can't imagine what else that would store. But there's even more problems here. Now we've got two different variables, buffer and buff, that are both the buffer to read to. And we've got all these pointers here that are pointers into the buffer. And there are actually three buffers in this function. There's buffer, buff, and then the parameter input buff. Like, these comments are absolutely useless. And so certainly in good code, we should not have blocks of local variables declared at the beginning of a function. This was ported from C originally. But even if you're porting from C, or even if you're writing C, we can use reasonable, useful variable names and not have to rely on useless comments like this. Similarly, these are all examples of comments that we found in our library that are absolutely useless for statements. Yes, let's add a comment to say that, we're going to lock the file here. And clearly that is what that function does. And if you spend any more than 5 minutes in this library, you would know that. But even in, fairly good-looking code, like this is a fairly okay-looking function, it's common to see, hey, I'll write a little comment to describe, what each part of the function does. And already, even in this example, like some of these comments are rather useless. Like that first part, okay, yes, the function is already well factored out. It's called get data from input file. I don't need a comment telling me this is going to get the data from the input file. Similarly, at the end, clearly that is going to print whatever the value is that we computed. So we can get rid of those. But then the second piece, like that is actually a rather useful comment because it tells you, okay, this is what the loop is going to do. But it would make a lot more sense if we actually just factored that out into its own function with a nice happy name like find largest value. And of course, we don't even need to do, once we've done that, it's easier to identify that, hey, there's actually already a function that does exactly that. And yes, we've omitted our error handling here for what if it returns, what if the range is empty. But we'll ignore that for the moment. And so once we've done this, now we've got this find largest value function sitting there that we're not using there anymore. So, I guess what should we do with that? We could comment it out. But we know that we don't want to comment out code like that because it's better to let the preprocessor use an if zero. Okay. Not really. I mean, we have source control, I hope. I hope everybody here is using source control. If not, then ignore everything we've said, and that should be your first.
Yeah, go do that.
Just please go do that. And so, just get rid of it. It drives me nuts when I go and find commented out code in our code base, and there is much of it. Some of which may actually date back to before we had source control. So there's other examples of this, though, like comments at the top of the file that contain the file history. Like, again, this is something that should be, recorded in source control. Or I think, I know you added this, so I don't know if you've seen actual examples of comments like within a file saying who changed, individual pieces
absolutely.
with rationale.
Yeah, and sometimes they'll be tied to work item numbers.
Yes.
Yeah, so there'll be like a comment, and then it'll say WI, and then some kind of tracking number from a ticket system, because that's again an unsolved problem. There's absolutely no way to tie a check-in to a work item, as you know, other than writing it inside the file. It's the only way to do that. You know what though? There was one comment I used to like, which was in header files. I like to have the comment with the name of the file until we got IntelliSense for includes in Visual Studio, and that because I would copy it. So I'd copy the name of the header and then go where I wanted and paste it in. Now I have IntelliSense, I don't need that one either.
And then finally, commented out code, just should not exist. It should not be a thing. Unless maybe it's a commented out example showing you how to do something with your library, perhaps.
So what do we hate? We hate code that sometimes I think deliberately obscures what it does to show off how smart the person is who wrote it. And I think we've all been guilty of that. And so a lot of what we're trying to advocate for, it's not just about being simple for the sake of being simple, but it's about intent and being able to communicate and actually treating writing code as a human-to-human activity rather than as a human-to-the-computer activity. So one of the reasons why macros are ugly is you are not talking to a human when you write a macro, right? You're talking to the preprocessor. And you are completely ignoring the needs or wishes or wants of the human who might come after you and try to read that or try to debug that or try to maintain that in any way. And so that kind of attitude shift of who are you writing this for, I don't know if it's possible to write macros for your fellow humans, but it's certainly possible to write actual C++ code like calling functions or declaring enums or whatnot for your fellow humans. And in fact, that's why we have enums, right? The only reason we want to say red and yellow and green is for the person who's going to read your code. If we were only doing it for the computer, we could just say numbers. So we also don't like walls of code. They're ugly for the same reason, because the human needs to read them. And then we start pulling in this nicer stuff. So make some lambdas. That way you have the locality. You have whatever the predicate is to the algorithm right there where the person's noticing that you're calling the algorithm and not in another file. Or actually worse than another file, 10,000 lines away in the same file. The other thing I find when I go into code where people have used function pointers, the really smart guys, is the names never match what they do. So the function's called like double it, and you go in there and it actually multiplies it by 3, right? But they didn't dare change the name. So lambdas make all of that go away, and you can just see that it multiplies it by 3 or whatever right there in the predicate to that algorithm call. And that's beautiful to us because that means the person who's reading it knows what it does.
This is actually especially a problem for very old code bases. I know that in our code base we'll have places that explain, we're using this technique, which we're not actually using anymore, because in DOS this other technique doesn't work, and in Xenix, which we also have to support, not anymore for 20 years now, this other thing doesn't work. And it's like, okay, none of that is even remotely of interest to us except for humor.
Yes.
And
So embracing lambdas, and yeah, okay, there's some punctuation. There is. But we're big people. We can handle a little punctuation in exchange for that locality of knowing exactly what's going on and where it's going on. And then making the background code, the cleanup code, like the house fairy that comes and tidies up when you're not looking, moving all that away off into destructors and other encapsulated places so that people can see what's going on. That's also beautiful because it takes away the effort for people to understand what you're trying to communicate to them with your code. Try to embrace other people's code as much as you can for the For the dog's body stuff, for the like I need to, I don't know, rotate a matrix or rotate a JPEG or unzip a zip or parse some JSON, there's no glory in that anyway. So use someone else's library, let them have a little bit of glory, and you write the cool stuff. And if you do all of this, and also the stuff we said on Monday, you might be able to cut your code base in half just by deleting comments, right? All those comments that explain things that don't need to be explained anymore and keep around that extra 200 lines of that algorithm you might need again someday. If someone is metricing your refactoring on lines removed, you can have a big win by taking away the comments you don't need anymore.
And with that, are there any questions?
Hello, stranger.
Hello. In a talk by Sean Parent on Lambdas, he mentioned Lambdas. He was very insistent that Lambda should not have more than one statement. But I've seen people use Lambda, especially inside of a function, for locality of code. They call the Lambda twice, say, within the function. They don't want to expose the code outside of the function. Just want to keep it local to the function, but it's more than one line of code.
I've definitely written multi-line lambdas when I was doing the C++ AMP work and also in the PPL where your continuation or whatever. I'll write 3, 4, 5-line lambdas. I don't mind that at all. I don't even think that's bad. Calling the same lambda twice, that's a different game.
I mean, actually, I'll be honest, I would not impose artificial restrictions on the size of a lambda. So for example, in the exception boundary technique that we showed on Monday, like generally what you'll do is you'll have a C function, and then you will wrap the entire body of that function in a lambda, and that could be arbitrarily long. Like, we don't want humongous functions, but sometimes long functions are acceptable. And so, in that kind of case, like absolutely, like it should be however long it needs to be.
I enthusiastically raised my hand when you said use other people's code. However, most of the time we do hit the difficulties of distributing the code with other people's libraries attached to it and their dependencies on. I was wondering, I really want to do this more and more, and do you guys have a suggestion, a solution? What is the best practice out there to wrap these dependencies and make sure that using other people's code is not really an encumberment to your distribution?
So you're not talking like legally or rights. You're just talking about the mechanics of getting the right files in the package.
Yes, and just giving it to people who are not programmers to compile your code, or just running binaries, try to statically link everything and give it to them, and it's basically that kind of question.
It's definitely going to be audience dependent. If you're allowed to statically link it, then that's obviously that's your simplest life, right? If the particular library you're using is one that you have reason to believe everyone already has, doesn't apply necessarily to us, but let's say the .NET framework, right? You don't want to necessarily distribute that. You want to maybe be able to count that that's on some Windows box or whatever. So it may be a similar thing. If you know your audience, if they're likely to already have those binaries, then you might want to try to make for a smaller deploy. So it's going to be case by case, but I would say this. Figure that out before you decide that's the library you want to use.
And just a second question about the comments. One thing that really annoys me are the licensing comments at the top of the files. Do you guys have a solution to that? I would love to erase those.
There is a list of licenses.
Sorry, I can't hear you.
So you're recommending an indirection. You're saying find the license, find the URL where the license lives, and just if you have to put a source code comment related to licenses, the comment should be the URL to the license terms, not the license terms. I like that. Thank you.
Yeah, I'm not a lawyer. I generally do whatever the license says to do. Like the Boost license has very clear instructions. Like just put this notice at the top of the file with a link to the license, and it's a one-line thing. But yeah, I've seen other things like Apache license code that has half a screen of text, and I don't know. To be honest, unless you're a lawyer, I would recommend just doing whatever the license says to do.
Just listen to the nice man in the expensive suit. Yeah.
Yeah. Andrew?
So I have the enviable position of being a professor and teaching undergrads. So I have seen just about every bad way that you can write code imaginable, like 90 times a semester multiplied by 5 per assignment. So do you guys have any advice for how to motivate people to actually care about their code quality? Like this is a constant battle that I have with my students.
It is. So I occasionally teach undergrads also, and I mark up their code the way I would mark up an essay.
Yeah.
I do. Like if I just think I'll say it works, but it's ugly, and I'll take red pen to their printouts or metaphorical red pen to the
Yeah,
files they give me.
It's the way that I grade too, but for some reason there seems to still be a barrier that people don't want to go back and look at the code that they've written. They don't want to improve it. They don't want to make it more readable.
Right. I think part of it is modeling. I mean, Bjarne said this a couple years ago, and it really stuck with me, where he said the reason so many C++ developers are still writing C is that some of their heroes started in C and absentmindedly write C when they're not thinking about it, and then they're like, oh, well, my hero is using malloc, so there must be a reason, so that's what I'll do, and that kind of thing. So printf versus cout, that kind of thing. So certainly like model, I would say that for sure.
Thank you.
And I think that until people actually work in the industry for a while, like it's hard to like impose upon people like this is really important, because if you have a few 100-line program that you've written for an assignment, like yeah, okay, it's complex, but who cares? It's it's this one file thing. But I think the other problem there, and I don't know what the solution to this problem is that there's so many terrible resources out there for learning how to program, and most people end up finding one of those first. And like on the other end of the spectrum, the 5th edition of the C++ primer. I don't believe that dynamic allocation is discussed until page 400 or something, which is terrific because you want to introduce the language and the simple pieces and how you write correct clean code before you get into the advanced parts of and here's how those containers are implemented. Here's how you would do these things yourself, and it's entirely in the from the point of view of, hey, these are advanced things that you need to understand, but that you shouldn't be doing all of the time all over your code. But I don't know how to force people to use this book and not any other, or
Your grade depends on this.
Yes, you can certainly say that. Yes.
So I want to jump the line for a second because I have a partial answer to Andrew's question, which is that when you write code for other people, the most important other person you're writing it for is yourself 6 or 9 months from now, right? So if you make those students carry that code forward in later projects, they're going to appreciate having written better code for themselves, right?
If you can get out of the 4-month term cycle.
On the subject of education, this is something I care kind of a lot about and have graduate background in. 2 things that I think help immensely, both at the undergraduate level and at the new employee sort of level, which is, first, you mentioned modeling. I posit that programming is the only skill and discipline where it is entirely likely that you will go through your entire formal training without ever seeing an expert participate in that activity, right? How often did you see a prof actually program? Right? And if you are not actually witnessing someone that knows what they're doing, how can we possibly expect them to have a sense of how to do the physical act of programming, debugging, rewriting, all of those things, right? So anyone that's an academic bent, please, live code. And then secondarily, practice, like the code katas stuff, and the code retreat stuff, and the find a really basic exercise and just do it, and then throw it away. Have your students do an exercise, and then ask them where's the effort? Right? Was it the thinking, or was it the 10,000 characters you typed?
So actually, that first thing that you said, so I contribute a lot on Stack Overflow, and it never ceases to amaze me that apparently, when people are teaching, programming, apparently they just completely omit any discussion of the debugger because nobody knows how to debug code. And that's shocking to me. How is the first day or the second day not, okay, I wrote this hello world and here's this magical debugger thing and I can step through it and, execute one thing at a time. These are absolute basics that.
Right. Yeah, absolutely. And if you haven't seen someone that you respect have a compiler error, you're gonna there's something wrong with me, right? Yeah, we have problems here.
Coding as a vocation versus computer science. That's what I think. We're both, and I love that aspect of it. Sorry, to skip back to the discussion about calling a Lambda twice, it just reminded me of a situation, and I don't know that this is the best way to do it, but I had a case where I saved a little snippet of logic, and then depending on the state of my thread run, I was doing some ASIO stuff. I posted that to a thread through like a package task, or I ran it locally. And it was really nice to be able to encapsulate that just little logical check in an auto, and then I could do the right threading decision. I didn't have to put it in a different function. It was very local. It was obvious, so I found that to be useful.
That obviousness, because, like, the comment's valid. The most important person is you later, The joke about your code's going to be maintained by a violent psychopath who knows where you live. I know where I live. So this is actually a true threat, because I'm not always a violent psychopath.
Oh, I was about to ask.
Hi.
Back to the licensing question, I just looked it up, but when we use SPDX, basically you just put a little string instead of your license, and then Google can find, through the code base, you can search.
So you're saying if you use the SPDX license, you can just include like a magic little token in the file, and the right things will happen for the
It's as
person.
good as your big chunk of
Yes. If you have to have licenses in your files, I understand if that's your unit of distribution, that's the unit that you're tagging with the license. But most of what we put in header files these days, whether it's the comments that explain that it was written in 1979 and who it's copyright by and all that other stuff, we don't hopefully need that anymore. But a license, that may be the one artifact that has to stay.
Yes, just do whatever the license requires you to do.
That's right.
Yeah.
Just comply.
All right.
I think we're out of time.
Well, thank you very much.
Thank you, everyone.